Okay, so we're going to be graphing the polar curve r is equal to cos 2 theta. We have a bunch of stuff written already. So we have up in the left-hand corner, upper left-hand corner, we have the Cartesian curve. So you see the vertical axis is r and the horizontal axis is theta, right? So this is just like r is equal to y and theta is equal to x. This would just be a regular Cartesian curve, right? So we're going to be using all of that information from the Cartesian curve, which is summarized in the table, to graph the polar curve. And we have we're just going to focus kind of on these important sections. So we have labeled, 1 to 8. So, and then we have kind of written here to help us guide ourselves through the problem or through the sketch, these angle measures: 0, pi over 4, pi over 2, 3 pi over 4, pi, etc., right? So for this example, we're going to have to be careful about the fact that r is negative for a lot of these parts of the curve. So let's just start with section 1, right? So theta is going from 0 to pi over 4, and r is going from 1 to 0. So we start out with that first point, right, which is just theta is equal to 0 and r is equal to 1. That's just this point on the polar axis, which corresponds to the x-axis, and a distance 1 away from the origin. And then we're going to rotate theta from 0 to pi over 4, right? And we're going to simultaneously kind of bring the distance r from the origin from 1 to 0, right? So like that. And that's 1. So now for 2, we notice this is where r starts to be negative. But we're going to use this fact here, right? This point negative r comma theta is equal to r theta plus pi, right? So what we can do is we can, to graph the values where r is negative, we can just graph it as if r was positive, right? So we'll have graphed r theta, and then, rotate that section of the curve theta radians. I'm sorry, pi radians, right? Okay, so now for section 2, right? So pi over 4 to pi over 2 corresponds to this little region here, right? We're going to pretend like r is positive. So let's just use a different color because we know that this is not actually a part of the curve. But if it were, right, it would look like this, right? So we're starting here where we left off, which is right at the origin. R is going to be going as we rotate theta from pi over 4 to pi over 2. So in this section here, r is going to go from 0 to 1, right? So that would just look like that, right? And so that is as if r is positive, right? But r is negative. So that's actually going to be over here, right? So that's that portion just rotated, this pi radians, right? Okay, so let me just kind of draw that a little bit better. Right, so that's 2, right? And I'll put here, maybe we'll make this right, I'll put here that this is 2, but the positive r version of it. And let me mark this over here as this was our 1. Okay, so now we are done with 2, and now we're going to do 3, but again, we have all negative values of r for this section, right? So as theta goes from pi over 2 to 3 pi over 4, we would be in this section here, right? This little wedge here. And if r were positive, right, then it would look just like this, right? Going from 1 to 0. That would be what that would look like. But we know that r is not positive, right? But we can just convert that by rotating that pi radians. So it would look just like that. And that's our 3. Okay, so then for the fourth section, r is positive, so we don't have to do that extra work. We can just plot right on here. So we know we're leaving off here at the origin, r is equal to 0, right? And we're going from r is equal to 0 to 1, and rotating from 3 pi over 4 to pi. So 0 to 1, just like that. Section 4. Okay, and so that's good. And again, 5, r is positive, so we can just plot directly on here. We have, as theta goes from pi to 5 pi over 4, we're in this little wedge here. And r is going to be going from 1, right where we left off, right, to 0, just like that. So it's 5. And then we're done with 5. Okay, so now for 6 and 7, we're back in negative values of r, so we have to do our little conversion here. So we're going to pretend like r is positive, and we're going to, theta is going to be going from 5 pi over 4 to 3 pi over 2, and r is going to be going from 0 to 1, right? So that actually corresponds to something that's already written on here, right? We're in this little section here from pi over 4 to, or 5 pi over 4, I mean, to 3 pi over 2. And r is going from 0 to 1 would just be the same exact part that we have drawn for 2. So that would be our 6, right? And then converting that, we have the the actual part of the graph is that section that we have written as 6 in the light gray, just rotated by pi radians. So that's going to be up here, like that, all right? And so that's going to be 6. We'll do that again for 7. So we'll start with taking taking r to be positive, and then we'll rotate whatever we have written down by pi radians. So we're for step 7, we're going to rotate from 3 pi over 2 to 7 pi over 4. R is going to go from 1 to 0. 3 pi over 2 to 7 pi over 4 corresponds to this little area here, and r going from 1 to 0 corresponds to this exact part written, labeled 3. And so that's like that, but let's actually not cover up the actual graph, right? Right, so like that. Right, so that would be our 7, but then we're gonna rotate that by pi radians. So we're actually going to go like that. Okay, and then we have our 7 is done, and our last leg of the journey here is step 8, from 7 pi over 4 to 2 pi. R is going to go from 0 to 1. We're positive, so we don't have to do this conversion. So 7 pi over 4 to 2 pi is this region here, this little wedge, and r going from 0 to 1. We're going to start here at the origin and go up to 1, and we see we're right back to where we started, right? So by the periodicity of cosine, we know that if we were to continue to graph more values of theta, this would just this pattern would just continue, right? So that's the whole graph, and we call it a 4-leaf rose. And yep, that's it.